Welcome. Thanks for attending the talk. So I'm Mark, and hiding behind the speakers is Mike, and we're part of Viacom Advanced Media Platform, which is a group that focuses on video for our public-facing sites and apps. And these are all sorts of ways you can reach us after the talk. So we're going to talk about Viacom itself, the real-time data proof of concept we put together. We'll talk about video performance metrics and how we're implementing them, lessons learned from using Spark and other technologies, what we're planning on in the future, and then we'll have time for questions at the end. So how many people here have actually heard of Viacom before that don't work at Viacom? Okay, good. That's awesome. That's awesome. We get a lot of that. Sometimes people don't know. So we earned over $12 billion in revenue in 2016. More than half of the top 20 kids programs aged 2 to 11 come from our content, primarily Nickelodeon, Nick Jr. And in case anybody's interested, SpongeBob SquarePants is coming to Broadway. They just announced that last week. As far as the software engineering team overall, both within Viacom Advanced Media and outside, we're a little over 300 software engineers in 9 countries. Lots of sites and apps supporting all of those brands. We're built very much on open source. Lots of different technologies: PHP, Java, Scala, Python, Swift. We're running primarily on AWS, Mongo, Cassandra, and of course Spark. We're going to talk about that today. Much of the work that was done, that we're going to talk about, is done over time by about a group of 6 software engineers. Some of it was actually referenced in the keynote this morning, so we will get a little deeper into that. The start of where we kind of started with big data in general is recommendations for music videos. We ran collaborative filtering on 40,000 music videos, doing item-to-item recommendations. Before that, we actually had a third-party vendor that we were using, and the guy standing behind the speakers and I said we could probably do better than them, and we did. We wound up with like 46% higher click-through rate using Apache Mahout and log files from our analytics vendor, refreshing that model about once a day. So based on that success, we wound up looking at real-time recommendations to do user-based, so we could actually recommend to individuals. And because of the limitations with our analytics vendor, we had to look at, we were looking at how do we do this in-house. And the analytics provider could only return data to us every 10 minutes, and they would charge for API calls. So we proposed that we actually do real-time data collection in-house, and there were a lot of, given that Viacom is a content company, and at the time it was a little bit of a tough sell to say we should be building out these large clusters and really pushing forward on real-time recommendations, but we managed to do that. So Mike will step in.
So what we needed to do is find out if we could collect data at all. We hadn't done any of this, and it was all new. And we talked about using fake data sets and generating sets of colors and see if we could aggregate that. And luckily, our friends at MTV News had a little social widget on their page, and they were able to give us a slice of their traffic of video views. It was a tiny message, user ID and video ID. And we built a little API using Nginx and Dropwizard that they could post the messages to. This is only about a developer and a quarter. It took us about a month to get this up and collecting the data. So they were posting that message to our little API. We were packaging those messages up and dropping them into Kafka. And we were using Apache Storm to aggregate them on different time windows. So we could see, oh, here's the most popular videos in the last 30 seconds or 5 minutes or what have you. And it worked. It was a good test for us for just collecting data. I don't think MTV News got much out of it because they did learn that their videos, their most popular videos didn't change much over the day. It was just, what was popular was always pretty much in the same order. These were news videos, not music videos, because MTV doesn't play music anymore. So now we were comfortable with collecting data, and we knew we were going to have to, process all the data that we're collecting. And an engineer that was working on the recommendation side started talking to Databricks and getting a POC going with them. And it's been adopted. I mean, we use it a lot, and we have 170 users. Some are engineers, some aren't. We have product people, analysts, data scientists. They're all in there digging through this data in their own way. So it's been great for that. Single place for everybody to work. We can manage the clusters there. We can schedule jobs there. We don't have the Wild West of people running all sorts of different versions of Spark and machines. So then the player team, our video player team, started sending us data. And that's been our focus. The recommendations thing kind of got deprioritized. We look at it once in a while, but that's not a focus for us at the moment. It's this video data. So we built out the collector a little more. And this is where we are now. So the Nginx Drop Wizard API layer, that hasn't changed. We still love Kafka. And the big change is now we use CCore, which is every couple of minutes grabbing the messages from Kafka and dumping them into S3. And that's kind of our master data layer. And then the bulk of the work is going on in Databricks. That's where everybody's working for the most part. Either they're streaming jobs that we have running in Databricks, and people are interacting with the data in S3, mainly in the form of Hive tables that have been created on various schedules. Underneath, this is not inclusive. It's just examples of other places where the data is landed. There's a phenomenon that as more people started seeing the data that we're collecting, they wanted it somewhere else. This isn't a shot at Databricks. It's just that's where they're working. So these are Cassandra. We ended up having a streaming job that's writing each user's place on a video. So we can, if they switch devices or log out and come back, they can pick up where they left off. There's some internal tools that are using Solar that wanted some visibility into the video data. So we have jobs that are augmenting a Solar collection as the day goes on. And my favorite is this New Relic, where one of our executives was interested in just one number from our video data, but he has his own dashboard in New Relic. He said, I want that number in New Relic, so we put it there for them. So sometimes you really need to put the data where your users are. As for the statistics of the data, it's about 1.25 terabytes a month. It's growing. There's some new types of data we're collecting, and as the homegrown collection gets rolled out to different apps and sites, we're seeing an uptick in volume. We average around 2,000-3,000 messages per second, and we'll see spikes. We've seen it get up, close to 20,000 requests per second. That was an awards show. I'll get to that in a minute. And viral traffic will drive it too. We saw Trevor Noah picked a fight with a guest, and that video went around, and that spiked it up pretty good. And we were the first ones to notice that it was going. We're like, hey, whoa, what's that? And as we saw the messages, the message volume increase. And it's JSON. They're posting a pretty healthy JSON message which we get loaded into Hive tables, and most people are interacting with the Hive tables, although some people do interact with the raw data itself. So the VMAs, this was the spike I was talking about and why we switched from Camus to C-Core. So the VMAs, that's MTV's big awards show of the year. It's in August every year. If you work at MTV, it ruins your summer. And it's the big event. And we really do, it is the test. If you have a system running, the VMAs is gonna test it, because that's the most traffic we get all year. And we saw it, and the show went live, and in 2 minutes we went from 2,000 requests to 18,000 requests per second. And so that was scary. Auto scaling doesn't help, because the machines aren't gonna be ready in time. The good news is we know it's gonna happen. So we had the extra hardware on hand. Camus got behind. That was what happened, is the data wasn't getting from Kafka into S3 and ultimately into Databricks fast enough. So C-Core has helped alleviate that. In the viral case, the growth is a little more gradual, so auto scaling will catch that. So living through the having this platform make it through the VMAs made us comfortable enough that we could start really digging into video performance on our own. And Mark is going to tell you all about that.
So the main sources for our metrics are first of all, we build our own video players, the iOS, Android, web. The video is such an important, it's everything for us, right? And this is where we make our money. This is what people come to our TV channels, our sites and apps to see. So it's incredibly important to us to be able to see what's going on in our players. And so we're collecting errors anytime we sort of categorize everything into things that affect user experience and things that don't. So there are errors that occur that do not really impact the user, but there are things that we kind of have to recover from, and nonetheless. And there are certainly fatal errors that crash players and really impact what the user's seeing, and we need to be able to track that. We have every 10 seconds during playback, there's a beacon call that's made to the system, and at the start of the video, and anytime you switch from an ad to the content is another point that we collect. And all of this is stored in, it comes through Kafka, stored in S3, loaded into the Hive tables, and accessible through Databricks. And the VPI is Video Performance Index. This is what the results of that data being collected, what we see in Databricks, what we look at every day, what people have on their monitors in their offices, what people are looking at to see how are things going with our player. So VPI is a combination of metrics for how long does it take. There's a threshold for how long it takes to get to the first frame of the video, time to transition from the ad to the piece of content, how many rebuffering events occur, how many fatal errors do we see. Any time we see one of those things in a single stream, that's recorded as a zero, basically, in our data, and we count that as a bad experience. So you can see we can break down the VPI into given a specific player. So in all these cases, the x-axis is the version of the player and the platform. So edge player is our web player, and you see a little bit of Android in there as well. So the other thing, so that's done primarily with batch and analytics. When we have live events like VMAs, like the movie awards, there are actually people who will watch charts and see things happen in real time. And when there's a problem, they'll call somebody. They'll yell at a CDN. They'll do whatever they need to do to make sure we're back up and running. So we had this show come on called Wonderland, where MTV is actually bringing back the music, and we had some cameras backstage that were only available online to a pretty small audience. So we wound up building out our streaming further based on that. So we can see these events coming in real time, and you can see here the granularity on the show that was on October 14th is much. It's much higher than when it was November 18th. So we really learned a lot through that experience, and we've made additional improvements. So the idea of if you haven't done things like this and you're going to, find your small use cases and build on it. So for the movie awards, which were when was that? It was a little while ago. We want to track, the number one metric that we try to track are concurrent users. So if we see at any point concurrent users drop, that's a big problem. That means something's wrong. That's kind of the big, aside from VPI, which is really used for looking at each player and seeing, should we go live? Do we need to roll back? How do we dig into the problem to figure out where we might see decreasing VPI, where this is really as we're playing out the video, the show. If concurrence drops, that's some indicator that something is very bad. So in this case, it was good. That thing on the end is just, there's no more data. So in this case, Edge Player is our, for the movie awards, was our biggest, was our most used player. And it was a pretty good show, pretty good event. So overall, some of the things we learned while we were doing this, I think we had a couple of revisions of how we aggregate the data. We collect the data, and then we're processing it, and really, the aggregations we've had to redo once or twice. And I think that's just a matter of bring people to the data and letting them explore it and figure out what do they need out of it, and reprocessing it. UDFs are fantastic. I think you heard that this morning at the keynote. It's just a great way to encapsulate logic that can be reused by data scientists, by data engineers, by anybody who just wants to run a report. And as with any data project reporting, traditional BI, otherwise, anytime you produce a new data source, you're going to have to. Somebody's going to say to you, "Well, that's not the thing that I've been looking at for the last 2 years, so it must be wrong," unless it's better unless you're producing better numbers. Then they'll get on board with you. But you always have to compare your pre-existing data. One of the cases we had were just concurrent users, actually. Some of the partners we have count concurrent users with a wider time range. So a session is a longer period of time. So we had to figure out what that looked like to say, look, if we just shift this time window to 5 minutes instead of 2 minutes, it's the same. It's basically the same numbers. So there's a lot to testing QA that you have to go through to get there. So for one of the other things we learned was when we stood up the real-time data collection system and the video player team came and said, "Hey, we want to use this," we said, "Great." They said, "What should the schema look like?" We're like, "I don't care. Just put it into Kafka and we'll figure it out." But it turned out that then we wound up being the ones to process the data and aggregate it and work on the reporting piece. So, we're going through another revision now in terms of the schema design. So you really should I think things are going to evolve. You're going to want to add things anyway, but we probably could have gotten there in the first place. I think as with anything running in EC2, which all of this is running there, Kafka, Spark, obviously, if we're using Databricks. Use the right kind of instances, and again, pre-process the data as soon as you know that what it's going to look like. We have event level data, which is always accessible, but we also have this summarized data, which it helps performance, so we don't have to spin up hundreds of nodes necessarily to run these reports. And as Mike said before, I think this is a big one. Your data should just go where the users want it. And I think that's one of the great things about Databricks, about these technologies, is you're just outputting files, so you can load them wherever you need to. And we do load into all of these systems for different use cases. We are looking at Elastic for some more real-time reporting and interactive reporting for the video performance metrics. Mike mentioned New Relic. Cassandra is collecting the resume play time codes. And we're not done. This is one of the things. Again, we're a video company, so content is everything for us. And we've covered the video player. We're still working on that, but we have a lot more to do. Being able to track throughout the entire content supply chain, throughout our details around ads and what's happening in the ads, when we're serving up our back end, which serves up the renditions, the video renditions, what is that doing? How's that looking? And we're even having some discussions about putting this on our linear systems. We actually have a homegrown linear playout. So if you're watching MTV, it's running off of a system that was built by developers at Viacom. So we should be able to integrate this into actually our linear playout system as well at some point, which is really pretty exciting for us. Trending dimensions, or basically trending topics. So we want to know when concurrent users drops. We want to know when any number of metrics drops, any of the VPI numbers, any of these things. So we're working, I think we have a first version in production last week of being able to alert on changes in concurrent users. And that's really important for operations teams, because this is for video on demand, so they're not going to sit there and look at every single stream. They need the alerts so that they know when things are going wrong on a specific video or a specific player or a specific site. I think sort of as engineers, we're always looking at options, looking at different ways to expose the data. So looking at ELK, again, we're starting to use it a little bit. QuickSight, Athena. We did look at Druid and Keeleen, which I just learned how to pronounce yesterday, thanks to that presentation. Spark ML, we're doing more with that. We want to be able to actually find those root causes in the data faster. We have extremely granular data. We should be able to expose it and use it to sort of predict when things are going to go wrong. Because one thing that we have seen is, before we had this, there observations. People would watch a video and they'd say, and they'd report, oh, I was having a problem with this episode of The Daily Show, but there wasn't enough data for us to say, okay, this is to extrapolate that into a systemic problem. But now we have that, and we want to build on it. And we actually want to do the continuous delivery into Databricks. So we're always publishing code, checking it into Git, and it runs all the tests and gets actually deployed into Databricks itself. I think that's about it. If you have any questions, I think that's all we have. Thanks.
Hi there. For things like a time to first frame, how are you like drilling into understanding what's going on there when you do see changes? Because often you'll see like exogenous internet events like DDoS attacks and stuff just cause a lot of traffic that might impact those metrics. So like, what's the process to really dig in there deeper than just that high-level chart that you have?
So it starts with that because we have all the event level data. So we see time to first frame took longer than X seconds. And we have what we didn't see were errors that the player's reporting, and you can dig into that and see, okay, this is a weird anomaly. This is actually something that we can control. I think that, yeah, that's one of the things you're dealing with the internet. So you don't always know if it's something you can deal with or not.
Hi, quick question on your message size. So how big did you say the message size was? And also, like, are you using things like compression, batch, and how many events do you process right now? And have you seen that grow in the last, like, let's say, year? What are projections going forward?
I'll go backwards. We were about 2,000 to 3,000 requests per second. Now we're maybe 4 or 5 is our average. The spikes are still the same. They get up, they approach 20,000. Okay. And then it dies off back to its normal.
And this
range.
drop wizard is just like on a set of VMs that you've deployed out on EC2?
Yeah.
Okay. And then how many of those do you need to scale to that level?
I think for the VMAs we used 25. I'm not sure. I'll get you the answer. I just don't know off the top of my head.
And then as you go out to other divisions and stuff, have you looked at like security and like doing some sort of access control for data? For like, you know, like certain groups can only access from certain topics, and as you build this pipeline out?
We're going to have to.
Okay.
You know, it's getting popular, and we're getting into the, into some areas where we don't want everybody looking at the data. Sure. Right now, everybody's welcome to look at our video data, because we're all kind of on the hook for it. And then also with the SpongeBob guys, we also have COPA stuff going on too. So, so security is going to be a big point. We just haven't tackled it yet.
All right, thanks.
Anything else? Okay.
Thanks, everybody.
All right. Thank you.